Alright folks, I just have something quick to show you here right now. We're going to be working today with the following concepts, if you're following along with your standards. We're going to be working with arrays, we're going to be working with loops. Most specifically, I'm trying to think what else we worked on here. That's pretty much it. I don't want to blow your minds here, but check out these triangles I can draw just by clicking the mouse. Yeah, you don't have to applaud, but I can hear it. Um, so what's happening here is I'm plotting a couple of random points and then just connecting them with lines. And whenever I click, I can change the triangle. What's really cool is that I have the program set, and I'll run you through it here in a second. I have the program set that I can jump this up to any number of points that I want. So you can see here I have an array going. Oh, let me pull the code down here so you can see it. I have an array going here. You can tell by the square brackets. And now I can reload this with 10 points, and the art gets a little bit cooler, doesn't it? I love it. There's something about this that I really, really like. I call it yarn art. I remember making this back when I was a kid with nails and string, this kind of thing. And this is the kind of stuff I would doodle in class constantly. And it turns out that it's pretty mathematically meaningful. If you really wanted to take this project to the next level, you might like try and shade these regions in right here. That's mind-blowing. Or to try to calculate where all of these lines intersect, that would be super, super awesome. That's the kind of quiz problem I might ask you. So, we're asking for some high-level understanding here. Just to kind of show this off a little more, we can take this to Crazy Town here. I'm going to check this out. So now it's going to run 50 each time. And it actually takes a significant amount of time for my processor to handle it. Look at that. Isn't that beautiful? Sort of. Maybe 50 is a bit too much, huh? But anyways, let me run you through the code here. Here's what's going on. We started off the program by declaring two arrays. An array is just a matrix of data. It's a single row of data. Think of it like this. 1, 2, 3, 7, 9, 24, 6, blah, 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 whatever. It's just a matrix like from math class. And each of these is indexed. So this is the 0th entry. Here's the first, second, third, fourth, and on and on and on. In processing, the way that we declare an array is we say we're going to have an array, which is this thing, these two square brackets, and then we're going to have an integers in those square brackets. So remember, the computer has to know what kind of memory usage you're asking for. And if you're going to make a whole matrix full of things, it needs to know whether those things are integers, whether they're floats, whether they're strings, because each of those represents a seriously different amount of ones and zeros that it has to pull apart and save just for that array. So we're going to make an integer array. It's an array of integers, just like I drew over here. We're going to call it x. These are going to be the x positions of our random dots. And we're going to say new integer, and then we can specify how many things are going to be in it. In this case, there's going to be 50 things in each array. We need these to match because we're going to keep track of the x and y coordinate in separate arrays. So this is how you build an array. There are many, many ways to build an array. And you should check out the processing website. Go to the API and check out array. There's a whole bunch of ways to make an array. Okay, this is just one. So anyways, what are we doing here? Well, let's set up the program. Let's set up a screen of size 500 by 500. We'll go small today. Let's make the background yellow. Let's set the stroke. This is the color of any lines that are drawn. So stroke implies color of drawn lines. Let's set the fill. We're going to set it to gray. We're going to set the fill to gray. So if we draw any shapes, we're going to fill them with gray. We're actually not going to draw any shapes today, so we actually don't need any of that code. And then we're actually going to smooth them out. This is called anti-aliasing. And anti-aliasing is just a way of sort of blurring the pixels so they don't look so jumpy. I like the way it looks. Okay, we're going to call the draw function here, but we're not actually going to do anything with it. See how these are empty right here? We have to call the draw function just so that the processing will draw something, but we're actually going to do all of our drawing in a completely different custom function. Well, not a custom function, it's actually built in. The built-in function here is mouse pressed. This is a special function. You can tell that because processing color codes it. Mouse pressed is a function that runs when you press the mouse. Surprise, surprise. If you spell it wrong, it doesn't work. At least I don't think. Let's run it and see. So if I spell it wrong, I have a lowercase p, and I click, no, nothing. It just ignores me. So you got to get this right. And you know, it's hard coded in. So under the hood, again, this is doing something. Okay, so what happens when we press the mouse? Well, we're going to redraw the background. Okay, so we're going to cover up anything that we previously drew. And now we're going to start doing some loops. You can see here I have 2 loops, actually 3. But let's concentrate on just this one loop. This is a for loop, and it's read in English like this. For the times when integer I, so this variable I, so for the time that I is equal to 0 and is less than the length of our array, which in our case is 50-ish entries. So for the times that variable I is between 0 and the length of the array, notice here we have I is less than, and we're going to step up I by 1. So for all those times, you know, in this case it's going to be 50 times, right? Actually, 51 because 0 counts. And I'll let you figure that out, whether it goes 0 to 49 or 1 to 50. You can kind of mess around with that. You got to get used to it. What we're going to do here is fill up our array. So we're going to say x of I. And this is super complicated here, and I need you to stay with me. X is an array, and the square brackets are where you are in that array. So if I said, here's my array, and I, at this moment, happens to be 4, then we end up at 0, 1, 2, 3, 4. And we're talking about this number 3. So what we've done here is use this stepping variable in this loop, and we've dumped it down here in these square brackets so that we can fill this array up with random numbers. You can see here I'm picking a number between 1 and 499. That makes sure that the dots stay on the screen because our screen is only 500 pixels wide. I probably could have just said width and height here, but whatever. In fact, you know what? Let's just do that so our program can be changed if we want. We'll go with width and height minus 1 so they're not on the edges. You know, just give it a little border. So here's the random function. We're filling up this array. Okay, notice here this for loop is going to run 50-ish times, and it's going to go x0, x1, x2, x3, x4, and fill it up with a random number each time. This right here is something you've never seen before. This is called casting. And casting changes a variable and makes it easier to use. So random spits out floating point numbers, which are decimals. But we declared that x would be an array of integers. So we need to change these floating point numbers and turn them into integers. And casting is done just literally with a variable type and a set of parentheses. If I got rid of these, you can see that processing will barf. See, it'll say, I can't convert float to int, wham, 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 wham. So you tell it, you know, go ahead, fine. Kill my floating point. So if this random number produces 5.3, just call it 5, man, and stick it in my array. Okay, now we have an array of x's and y's. And what we're going to do here is really fancy. We're going to loop through each of those numbers. So again, we're going to start on 0 and loop through the length. And you can see here, now I'm going to go through length minus 1. Okay? And we're going to go up by 1s. So we're going to loop here for each time in the array. What we're going to do is take a step through the x array. And then we're going to, once we hit each part of the x array, we're going to loop through again starting at 1. So we're going to skip the 0th entry and we're going to loop through again. So we're going to say z is 0. Okay, well j is going to go 1 through 50. Okay, well then z is going to be 1. Well then j is going to go 1 through 50. So what we see here then is inside of this final loop we actually draw a line. And that line is at the position where z is, and it connects to wherever j is. So we take a dot and we stick there, and while we're stuck on that dot, we actually loop through and hit every other dot, thus connecting it like a yarn art. So this loop within a loop thing here is pretty complicated, but I just want to show it to you because honestly I think it's pretty awesome, to tell you the truth. I definitely have some shenanigans here with some things going on that I'd like you guys to play with. Feel free to steal this code and make this way cooler than how I have it. Let's see if we can break it though, just for giggles. Let's see if we can make it to 100 points here. Load it up, click. Oh my gosh. So you can barely see anything in there anymore. And it takes, honestly, almost 2 seconds for it to process all of those points. If you think about how much it's processing, it's stepping through 100 times and connecting almost 100 lines for each step. Now there's got to be a more efficient way to do that. And I'd love to leave that up to you guys. The types of quiz problems I might ask you would be like, what is the most efficient way to create a loop to go through a bunch of these things? Those are the kinds of questions I might ask. So feel free to dig into that. Hope you enjoyed this thing. Let me leave you with some actually, good looking art here. I want to leave it on that blob. So let's just do 14 and see if that looks good. Look at that. Isn't that cool? Alright folks, we'll see you at office hours.